Hello everyone, welcome to our new lecture. In this video, we are going to see an example of CYK algorithm. So, at first, why do we use CYK algorithm? We use CYK algorithm to check whether a particular string can be generated from the grammar or not. But at first, we need to remember that to apply CYK algorithm, our grammar have to be in CNF form. So, if our grammar is in CNF form, we can check whether a particular string is can be derived from that grammar or not using CYK algorithm. So, how do we do it? We do it using a table format where each cell of the table represent a substring of the actual string. So, at first if we look our string in this example, we are going to check whether the string B double A B A can be derived from this grammar or not. So, if we check that our string has length of 5, right. So, in a string, what's the lowest level can a string have, a substring be? The lowest, the length of a substring can be 1, right. So, if a substring length is 1, we can get 5 substring from this string of length 5. So, if our string is BAA, so this is the string of length 5, we can get 5 substring of length 1 from this string, right. One is B, one is A, then B, then A, right. So, as we can get 5 substring of length 1, so the first column, the first row of our table will have 5 column. So, these are the 5 column, this is the lowest row of our table and the 5 column, column 1, column 2, column 3, column 4 and 5. So, this is the column which is one, which contains the position 1, then the 2, then 3, then 4, then 5, and our string, the positions, in the first position our string has B, then A, B, A. Now, in the next step, in our first step, all the substrings were of length 1. Now, in this next step, our substring will have length 2. So, the first substring we can get is from position 1 to position 2. So, 1 2, right. After that, we can get the substring 2 to 3, from position 2 to 3. So, 2 3, then we can get 3 4, and then 4 5. Look, after this 4 5 we can't get any more column in this row. Why? Because then that will be 5 and 6, but we don't have any sixth character, right. Our length is 5, so this length 6 can be possible. So, the 5 6 won't be there. So, after that we will have the substrings of length 3. So, the first column will have 1 to 3, from 1 to position 3. After that we will have 2 to 4. So, 2 4 and then 3 to 5. See, we can get any more column because that will be 4 to 6, but our string is of length 5. So, 6 can be possible. And then in the next row we will have substrings of length 4. So, that means 1 to 4, then 2 to 5. and after that the substrings of length 5, that means our main string by our original strings, which is 1 to 5, right? Now if now what we will do, we will fill up this table and check for fill up this table by checking how can we generate the substring. So at first let's produce this b. B can be, if we look our grammar, b can be generated from the variable b, right? So we will fill up this cell with b. One second. So we'll have okay b. Now in our next cell in position 2 we have a. Now how can we generate a? We can generate a from a and c. That means we will fill up this column, this cell with a, c, and then from this tree it will also be ac, because we can generate a from variable a and variable c. So a and c. After that we have b. Now how can we generate b? We can generate b from b. So b, and then the a, we can generate a from a and c. So a, c. Now let's fill up this rows too. So in this row we have the substring 1 2 from position 1 to position 2, so that is ba, right? Now we can generate b, or we can generate the position 1 from b, and then the position 2a we can generate it from a and c. So a and c. Now what we will do, we will cross product these two sets, which gives us ba, bc. Now we will look in this grammar and check whether we can produce ba or bc. So ba can be produced from a, right? Ba can be produced from a, so this can be produced from the variable a. And bc, well, bc can be produced from the variable s. So this is s. So we have a and s that can produce the substring ba. So s and a, right? After that let's look at the look at the substring from position 2 to position 3, which is double a, right? So now this a of position 2 can be produced from a and c, and the position 3 it can also be produced from a and c. Now the cross product will give us double a, ac, ca and cc. So now what we will do, we will check in the grammar and see if these productions can be produced. So aa, we don't have any a in our grammar, so this is eliminated. Then ac, we don't have any ac either, so this is also eliminated. ca, we also don't have any ca, so this is also eliminated. But we have cc. Where do we, from where we can produce cc? Cc can be produced from b. So that means in this position 2 3 we will fill up it with b. After that look at the position 3 4. So in 3 4 we have A B. So now this position 3 can be generated from A C, and this position 4 can be generated from B. So this gives us, the cross product of these two gives us AB CB. Now if we look into our grammar, we can see that AB can be produced from S and C. So this gives us S and C. But can we produce CB? Look, we can't produce CB, so this is eliminated. So we are going to fill this cell with S and C. S and C. Now let's look into our last cell, which is 4 5. So this 4 5 gives us BA. Now from where we can produce this position 4? We can produce 4 from B, and the position 5, which is A, we can produce it from A and C. We can check this into our table. Here is the position 5, which can be generated from AC, and then the position 4, which can be generated from B. So the cross product of these two will give us BA and BC. Now look into our grammar. Can we produce BA? Yes, BA can be produced from A. And can we produce BC? Yes, BC can be produced from S. So this gives us S and A. So let's fill up this with S and A. Now this was the easy part. Now we will fill up the row 3, and this is where the solution will get a little bit tricky, and I need you to keep your attention from these steps because it's a bit tricky. So now in the first column of third row, we can see that our substring is from position 1 to position 3. So now from position 1 to position 3, the substring is B A A. This B is from position 1, this is from position 2, and this is from position 3. Now what we will do is we will break this substring BAA into some combinations of more substrings, right? So now how can we break this BAA? Look, we can break this BAA into by taking this first B and the rest of the A and A. So this is our one combination. Then we can also break it in by taking at first BA, so BA and then the rest of the A. Now if we move forward one step more, we will get a substring BAA, but we want to make this BAA. So as we are going to make this BAA, we won't take it. So this is our two combination. By how we can make this BAA. Now this B is from position 1 and this AA is from position 2 to position 3, and this BA is from position 1 to position 2, and this A is from position 3, right? So at first we are going to make this first set of combination. In this first set of combination, at first we need to make B, which is from position 1. So how can we generate these substrings of position 1? We can generate it from B. Look in our table. Where is this position 1? This is my position 1, and we can make this position 1 from B. So this is B, and this position 2 3, look in the second column of our second row, this is position 2 and 3. So we can make this position 2 3 from B. So now if we cross product this, we will get B B. Okay, now check the another set of combination. In the first we have from position 1 to position 2. So where is the substring from position 1 to position 2? It is in the first column of our second row, which is position 1 and 2. So this can be generated from S and A, and then the rest of the part is position 3. So how can we generate position 3? In the third column of our first row, we can see that position 3 can be generated from A and C. So A and C. Now if we cross product this, we will get SA, SC, double A and AC, right? So we can create this BAA from this BB and this 4 combination where SA, SC, double A and AC. So now we will check that how can we get these combinations from, or we get these productions from our grammar. So can we get BB? In our grammar there is no BB, that means we can't get this BB, so this is crossed out. Now check SA. Can we get SA? In our grammar there is no SA, so this is also out. Then SC, we can't get any SC, so this is also crossed out. Double A, there is no double A, so this is also crossed out. And the last one is AC. Do we have AC? No, we don't have AC. So as we can see that none of these 5 production is in our grammar. So that means we can't generate the substring BAA or the substring from position 1 to position 3. So this will be blank, or you can say empty. Now check the substring from position 2 to position 4. So from position 2 to position 4 we have A, B. So this is 2, 3, 4. So now break this into different substrings. So at first we can take A and AB, and then we can take A and B. So this is position 2, this is position 3, 4, this is position 2, 3, and this is position 4. So let's check the first one at first. How can we generate A or the position 2? We can generate position 2 from A, C. And how can we generate position 3, 4? Well, in the third column of our second row, we have 3, 4, which can be generated from S and C. So the cross product will give us AS, AC, CS and CC, right? Now check the second combination. At first we have double A or a substring from position 2 to position 3. So how can we generate it? Well, in the second column of second row we can see that from position 2 to position 3 we can generate it from B. And how can we generate the substring B or position 4? Well, position 4 can be generated from another B, that is in our fourth column of first row. So this production will give us BB. This cross product will give us BB. Now we don't have any BB in our grammar, so this is crossed out. Do we have AS? No, we don't have any AS, so this is also crossed out. AC? No, we don't have it either, so AC crossed out. CS? No, there is no CS, so crossed out. CC? Yes, we can generate CC from B. We can generate it from B. So we will fill this cell with B. right. Now the substring from position 3 to 5. So from position 3 to 5 we have the substring ABA 3, 4 and 5. Now break this into different substring. We can get at first A and the BA. We can also get it from AB and A. This is from position 3 and this is from position 4 and 5. This is from position 3, 4 and this is from 5. Now how can we generate this A or position 3? Well, in our table we can see that position A can be generated from A and C. So A, C, and the position 4, 5 or the substring BA we can generate it from S and A. Look at the last column of our second row. There we can see that from position 4 to 5 the substring can be generated from S and A. So S, A. So the cross product will give us AS, AA, CS and CA. Now check the second combination where at first we need to generate AB or from position 3 to position 4. So how can we generate from position 3 to 4? Well, in the third column of second row we can see that the from position 3 to 4 we can generate it from S and C. And how can we generate the position 5? Well, it can be generated from A and C. You can check it in the table. So now the cross product will give us SA, SC, CA and CC. Now we need to check that whether these productions are in our grammar or not. So we don't have any AS. So this is crossed out. AA, we don't have it either. So crossed out. CS, we don't have this. CA, we don't have it. So crossed out. Well, alright. Now do we have SA? No, we don't have any SA nor SC nor CA, but we do have the production CC where we can generate CC from B. So this means the 3, 5 can be filled with B. Alright. Now we need to complete the fourth row. We are pretty much closer to our solution. So from position 1 to 4 we have the substring B, A and B. So this is 1, 2, 3 and 4. So what we will do now? We will break this substring into combinations of different substrings and we will try to generate them. So at first we can break it into B and the rest of the AAB. Then we can break it into again with BA at first. So this is BA and the rest of the substrings which is AB. Then we can break it as BAA. So BAA and the B. Now we won't take this whole BAAB together because we are making the BAAB. So this B is from position 1 and they are from position 2 to position 4. They are from position 1, 2 and 3, 4. And they are from position 1 to 3 and position 4. So now how at first if we look in this first combination, how can we generate this B or position 1? Well, we can generate position 1 from B. and the position 2 4. Well, in the third column of our second row we can see that position, sorry, it's a mistake. In the second column of our third row, if we look at the second column of our third row, we can see that from position 2 to position 4 we can generate it from B. So this cross product will give us BB, right? So we are done with this first combination. Then in the second combination we need to at first create from position 1 to position 2. So in the first column of our second row we have from position 1 to 2, which can be generated from SA, and the position 3 to 4 can be generated from SC. So if we cross product we can get SS, SC, sorry, this is SC, then AS and AC, right? Now can we generate, we have another one which is from position 1 3 and 4. Now how can we generate position 1 3? Well, we can see that in the first column of our third row we have position 1 to 3 which can't be generated. As from position 1 to 3 can be generated, that means this combination is not possible, so it is crossed out. So now we can check that if these productions are in my grammar or not. So BB is not in my grammar, so BB is crossed out. So now check whether SS is in my grammar or not. SS is not in my grammar, so it is also crossed out. SC, this is also not in my grammar. AS, not in my grammar. AC, this is also not in my grammar. That means from position 1 to 4 can't be generated. Now we have two more boxes to fill up. So from position 2 to 5 we have AA, BA, 2 3 4 5. Now check whether we can generate this or not. So at first we need to break this into combinations of more substring. So at first we can break it as A and ABA. Then we can break it as AA and BA, and the last one is AAB and A. This is from position 2, this is from position 3 to 5. This is from position 2 3 and 4 5, 2 to 4 and 5. So how can we generate this position 2? Well, in our table we see that position 2 can be generated from A and C, and from position 3 to 5, well, in the last cell of our third column we can see that position 3 to 5 can be generated from B. If we cross product we will get AB and AC. Now we are done with this combination. Now the second one. At first we need to make AA, which is from position 2 to position 3. So we can see that from position 2 to position 3 we can generate it from B, the second column of our second row. Now from position 4 to 5 these can be generated from SA. Look at the last column of our second row. So the cross product will give us BS and BA. Now we need to make, we still have one combination left, which is from position 2 to 4 and 5. So from position 2 to 4 we can see in the second column of our third row that from position 2 to 4 can be generated from B, and the position 5 can be generated from AC, the last column of our first row. The cross product will give us BA, BC, right? Now we need to check whether these productions are in my grammar or not. So BS is not in my grammar, so this is crossed out. BA, BA is in my grammar, which can be generated from A. So this can be generated from A. So then this BA can be generated from A. This BC, well, we can generate BC from S. Look here, can generate BC from S. So this BC can be generated from S, and this A was from A. Okay. Now AB, can we generate AB? Yes, we can generate AB from symbol S and symbol C. So this can be generated from S and C. And AC, well, AC can be generated. So that means we can produce the substring from position 2 to position 5 from S, S, A and C. Alright. Now we have our last cell to fill up. So in the last cell, which is from position 1 to position 5, we have BAA, which is our string that we are checking that can be generated from this grammar or not. So we can break this as B and double A, BA. After that, we can also break it as BA and ABA. Then B double A and BA, and the last one is BAAB and A. Well, this is position 1, this is from position 2 to 5, this is position 1 2, and it is from 3 to 5, this is 1 3 and 4 5, this is 1 to 4, and this is 5. So how can we generate this position 1? Well, we can generate position 1 from B, right? The first column of our first row. And position 2 to 5, well, we can see that position 2 to 5 can be generated from SAC, the last column of our fourth row. That is from position 2 to 5, which is SAC. Now the cross product will give us BS, BA, BC. So we are done with this. Now check the second one, that is from position 1 to 2. So how can we generate position 1 to 2? Well, the first column of our second row is from position 1 to 2, which is SA, and the position 3 to 5 is in the last column of our third row, which is from B. So if we cross product, we will get SB and AB. Well, for the from position 1 to 3, we can see that position 1 to 3 can be generated in the first column of our third row. As position 1 to 3 can be generated, this combination is crossed out. Same from position 1 to 4, we can generate any substring from position 1 to 4. So that means this production is also crossed out. So we have left with 2 production, and we already done with computing that. So now we need to check whether these productions are in my grammar or not. So BS is not in my grammar, right? So this is crossed out. BA, we have BA. BA can be generated from A. BC, BC can be generated from S. SB can't be generated, but AB can. AB can be generated from S and C. That means we can produce this 1 to 5 or the substring from position 1 to 5 from S, A and C. So now once again, this is not completely clear, I guess. So let's write it in. So let's write it clearly. So okay, this is S, A, C, right. Now we need to check whether this, now we are already done with completing this table. Now our task is to check whether this this string BAABA can be generated from our grammar or not. So in this grammar, what is, at first look at the table. The BAABA or the string from position 1 to 5 can be generated from the variable S, variable A and variable C, and in this grammar the start variable is S. Now we can see that the string BAABA can be generated from S, which is our start symbol. As the S or the start symbol is in this set, we can say that this string BAABA can be generated from this grammar. Alright. So I guess I was able to clear I was able to make you understand this. So thank you.